Welcome back, everyone. Today's explainer is essentially your university masterclass on Chapter 25 of our software engineering journey. Today, we're zooming in on Section 25.4, which is all about release management. And then we're going to wrap things up with an essential master recap of the entire chapter to really finalize your exam prep. I am absolutely thrilled to be your guide through this. As we go along, I'm going to use these visuals to make even the most complex, behind-the-scenes logistical processes of software engineering perfectly clear. Okay, so here is our syllabus for today. We're going to rigorously cover the exact steps of release management. We'll start with what a release actually is, break down its anatomy, explore the incredibly tricky business decisions behind it, and look at the absolute nightmare that is custom software. After that, we'll see how software as a service is totally changing the landscape and finish up with our master recap. Right. Section 1. Introduction to System Releases. Let's dive right in by establishing exactly what happens when software is, well, finally ready for the customer. Up until now, we've mostly talked about versions of code just sitting on developer machines or central servers. But eventually, that code needs to face the real world. So we must first properly define what a system release actually is before we get into the logistical headaches. Simply put, a system release is a version of a software system that is formally distributed to customers or end users. It's that major transition from a purely internal development artifact into a public-facing product. Now, in mass-market software, we generally see two distinct categories of releases, and you'll want to note the difference carefully here. Major releases deliver significant new functionality, and they are usually paid for by the customer. Minor releases, on the other hand, well, they repair bugs, fix minor customer problems, and are almost always distributed free of charge. For example, if you're running an operating system version 10.9.2, that generally means you're on minor release 2 of major release 9. So, to recap, a release is simply the distributed software, fundamentally split into major functionality upgrades and minor bug fixes. Moving on to Section 2, Anatomy of a Release. What exactly makes up a release? A very common misconception students have here is thinking a release is just the executable code, the raw program itself. But in professional software engineering, that is only a tiny fraction of the story. In reality, a release is vastly more complex. Yes, you have the executable code, for sure, but it also includes configuration files that define how the software should behave on specific hardware. You need data files, like language packs for error messages in different regions. You've got to have installation programs just to get the software onto the target device. Then there's the electronic and paper documentation, and finally, for mass market products, the packaging and publicity materials. So just to briefly recap this part, a system release is a comprehensive package of supporting assets, not just a raw program. Section 3, the business of releasing. Now that we know what a release is, let's look at the strategic side. Deciding exactly when to push a release out the door is honestly one of the most difficult business decisions a software company has to make. We call this the timing dilemma. Think about it. If you release too often, especially if those releases require hardware upgrades or a new payment, customers get annoyed. They get upgrade fatigue and will just flat out refuse to install the new versions. But on the flip side, if you release too slowly, you lose market share to competitors who are constantly adding exciting new features. It's a very delicate balancing act. I'd highly recommend paying close attention to these next points for your exams. There are 4 critical factors that dictate exactly when a business decides to launch a new release. First up is competition. You might literally be forced to release early just to match a rival's new feature. Second, marketing requirements. Maybe your marketing department has already publicly promised a release date, so you're locked in. Third, platform changes. If Apple or Microsoft releases a new OS version, you have to adapt your software to keep it working. And fourth, technical quality. If a critical bug is found, you have absolutely no choice but to issue a minor release immediately. And as you can see illustrated beautifully here, these factors constantly pull and push against each other. Critical bugs demand technical quality updates, while a brand new OS forces platform changes. The main takeaway? It's never just about when the code is done. The release date is heavily influenced by the market, the platform landscape, and sheer competitive pressure. Once that tough business decision is finally made, the actual creation of the release follows a strict 6-step process. First, you identify the exact executable code in your version control system. Second, you write configuration descriptions for different hardware setups. Third, you write the updated customer instructions. Fourth, you script the installation programs. Fifth, you create the web pages and publicity links. And finally, step 6, you prepare the master image, which is the single executable package ready for distribution. So to recap, release timing is a delicate business balance executed through a rigorous 6-step creation process. All right, Section 4, custom releases and documentation. Releasing mass market software is hard enough, right? But as we're about to see, custom software is a whole different beast. We actually call this the custom release nightmare. Let's imagine a company that builds specialized firefighting vehicles. They don't just maintain one standard piece of software. They might have 100 different customers running 100 slightly different variants of the software, all tailored to specific individual equipment. A software company in this space has to track exactly which customer has which release and how those releases interact with individual physical systems. It's a logistical maze. To survive this nightmare, perfect documentation is absolutely essential. You can't just save the code and call it a day. As highlighted here, you must record and store the specific versions of the source code, the operating system, the libraries, and the exact compilers used to build it. You might be wondering, why go to all that trouble? Because you must be able to recreate exact builds years down the line. Consider military or embedded systems that have 30-year lifetimes. 10 years from now, a military client might need a highly specific bug fix on an obsolete version of the software. You literally have to preserve those exact obsolete compilers and OS versions, often running them in virtual machines today just to compile the old code. So, to recap this section, custom software requires meticulous archiving of every single tool and environment to ensure reproducibility decades later. Which brings us to Section 5, the SaaS solution. So, how do we solve this legacy hardware nightmare and the persistent problem of customers simply skipping updates they don't want? Well, the answer lies in the cloud. Let's formally define SaaS, or software as a service. This is software hosted remotely and provided entirely over the internet. It solves the installation problem completely because, quite simply, customers don't install anything locally. The software lives securely on the provider's servers. The benefits for release management here are massive. With SaaS, the developer pushes updates directly to their own servers using distribution tools like Puppet. This means simultaneous global rollouts. No user can skip an update because the developer controls the server environment. Everyone is instantly on the identical latest release. To recap, SaaS eliminates version fragmentation entirely by centralizing the release environment. And finally, Section 6, the Chapter 25 Master Recap. Congratulations on making it through the complexities of release management. Now, let's do a rapid-fire master recap of the whole chapter to really solidify your exam prep. We're going to stitch together all the core concepts of configuration management. Remember from earlier in the chapter, we looked at version control. Centralized systems, like Subversion, use a single master repository on a server. If that server goes down, all work stops. Distributed systems like Git, however, give each developer a full local clone of the entire repository. This allows for offline work and provides automatic backups across the whole team. Let's also review these essential definitions. System building is the automated process of compiling and linking component versions to create an executable. For your exams, remember the break the build rule in continuous integration. If a developer commits code that causes the automated system build to fail, they have broken the build and must fix it immediately. Also recall the Change Control Board, or CCB. This is the formal committee that reviews, evaluates, and approves or denies proposed changes to the system baseline. So the crucial point to remember is that configuration management rests on these 4 pillars. Version management tracks your code lines and baselines. System building compiles them. Change management, which is governed by that Change Control Board, handles evolution and bug reports. And finally, release management, which we learned all about today, delivers that final product to the world. Together, they ensure that software behavior remains entirely predictable, manageable, and reproducible. As we wrap up this explainer and close out our chapter on configuration management, I want to leave you with a bit of a provocative thought regarding the future of software engineering. If SaaS allows developers to continuously push minor updates directly to remote servers every single day without the user ever lifting a finger, will the traditional, heavily marketed system release eventually disappear altogether? Will users of the future even know what version of a software program they're running? Thank you for joining me for this masterclass, and keep questioning the systems you build.